In this video, we'll continue with understanding the structure of an atom and what is an electronic arrangement in an atom. How are the electrons exactly arranged around the nucleus? To understand that, we'll first try to understand what are electromagnetic radiation. So essentially, we are surrounded by electromagnetic radiation. Everything that we use, from starting with like visible light that we see, X-rays, microwave rays, radio waves, all of those are basically part of electromagnetic radiation. This is the entire wavelength or the spectrum of electromagnetic radiation. So this is called the electromagnetic spectrum. What you see right here is called wavelength. Wavelength is essentially electromagnetic radiation can be regarded as waves. So just like how ocean has some waves, if you have waves that are big and small, this distance between the peaks of two waves is called the wavelength of um, this particular wave. Same is true for electromagnetic spectrum. The distance between these waves, the peaks of these waves, is essentially called the wavelength of this particular radiation. Now, if the wave is really fast, it is high in energy, it's really fast, what would happen? The distance between the peaks is going to reduce. That means that the wavelength will be lesser. So if the wave has high energy, then wavelength is small, and vice versa. Meaning if the wave has less energy, wavelength will be a larger number. Okay, so what you're seeing here as we are going further down in this electromagnetic spectrum, you can see that the wave kind of is going faster. As the wavelength is decreasing, you see here the power exponent is becoming more negative, so which means the wavelength is decreasing. As the wavelength is decreasing, you can see that the waves are becoming closer and closer. That means they're going faster and faster, so they have higher energy. So that's what you see right here. The wavelength is decreasing and energy is increasing. And frequency is essentially the opposite of wavelength. It behaves opposite of wavelength. So as the wavelength is decreasing, the frequency is increasing, and so is the energy. And here you can see in the spectrum, there are multiple types of waves: radio waves, microwaves that work in a microwaves, infrared radiation, UV radiation that is present in the sunlight, X-rays, gamma rays. These are all different types of electromagnetic radiation. Now, why are we studying this? Essentially, if we take this portion of the electromagnetic radiation, which is called the visible light, which is called visible because it's visible to us, visible to our eyes, human eyes. If we take this light and pass it through a prism, the prism essentially will diffract this light in a way so that we can see different colors, or it breaks apart this light into different colors. It breaks it into a rainbow, essentially what we call a rainbow. All different colors in the visible light can be seen. Now, if the same light, instead of using the light coming from the sun, if we use light that is coming from atom, if we heat up an element, let's say, and we pass that through a prism, in that case it will not no longer be a rainbow, but it would give you more like a line spectra, where we'll see different lines of different colors being visible to us, something like this. This is referred to as the atomic spectra. So basically each element has its own unique atomic spectra, so each element will produce different color, distinct lines of different colors, and each of these colors would essentially be separated by some darker areas which would look black to us. So this is called the atomic spectrum. And why do atoms produce such kind of spectrum, and why the spectra is distinct or specific towards different atoms? That is because of the arrangement of electrons around the atom. So up until now, we saw that in a structure of atom, an atom consists of a nucleus, which is dense part, which consists of protons and neutrons, and around that we saw there would be some electrons. Now these electrons are not just randomly present in any space around the uh, nucleus. They are present at certain energy levels, at specific energy levels, which are called as electron energy levels, or they are also referred to as orbits. Okay, these the energy of the electron is essentially fixed. It is called quantized, which means that electrons can have only specific energy values, which means if let's say this is an atom, if this is an atom, the nucleus is right here. These are the different energy levels that are present around the atom, around the nucleus. So the quantized term essentially means that electrons can only be present at this energy level, or at this energy level, or at this energy level, or here, or here. Basically the colored regions that you are seeing. Electron can be anywhere around in this particular orbit, in this particular energy level. The space that you see between two energy levels, electrons can never be present in this empty space. That space is always going to be empty, and this is what is called as quantized, meaning electrons can only have a certain amount of energy. They can never have anything in between. These energy levels are usually referred to by a number which is called the principal quantum number. You can essentially regard this as an address to an electron. So that essentially means if I'm talking about electron, where would that be present, located? What is the exact location where we can find electron in an atom? So this number exactly tells us what is the location of the electron around an atom. For instance, if I say an electron is present in the principal quantum number 1, that means I will basically find the electron somewhere right here. If it is present in n equal to 2, I'll find the electron somewhere right here. So this is essentially telling you the exact location of the electron in an atom. This is also abbreviated with the alphabet N. So, and these basically can go from 1, 2, 3, 4, 5, depending on how many electrons do we have. Another important thing is when you're filling the electrons in an atom, the shell number, this electron orbit or the energy level number 1 always consists of maximum 2 electrons. This can only hold 2 electrons. All the other shells can go up to 8 electrons in total. Okay, now how many electrons does each orbit contain? That would depend on what atom we are talking about. As we know, based on our previous video, we saw that we can figure out how many electrons are present in an atom. So if we know the number of electrons, we can basically distribute atoms around these shells. The only important thing is that we always fill up the first shell that we always fill up is the one that is closest to the nucleus. So you always start filling electrons from closer to the nucleus, and then you go further away from the nucleus. And always the shell number 1 or the orbit number 1 consists of 2 electrons, and then all the following orbits will maximum hold up 8 electrons. So you start filling up shell number 1, then if you have more electrons, then we move to number 2. If we have more electrons, then you move to number 3. Okay, so let's see, based on this, um, to give you another example of what exactly quantized mean, just like how, let's say if a person is climbing a ladder, where can we find the person's feet? They would either be on step number 1, which is n equals 1, or step number 2. You cannot find the person's feet hanging anywhere in between these two steps, right? So that means something can be only found at n equal to 1, or step number 2, or step number 3, 4, 5, 6, whatever. So that is exactly what energy levels are. You can only find electrons in either quantum number 1, quantum number 2, 3, 4, but you can never find the electrons in between these quantum numbers. So now we were talking about atomic spectrum. What happens? What is atomic spectrum? So essentially what happens when Another important thing when we talk about energy levels is that the electrons that are closest to the nucleus have the low energy. So this right here, energy level 1 is the lowest energy. Okay, as we progress away from the nucleus, the energy level increases. So this is high energy, this is higher. As we go farther away, it gets higher and higher in energy. The lowest energy is right here. So when an electron is present in its original location, for instance, let's say some electron was present right here at n equal to 1. It has 2 electrons in this energy level. This electron, when it's present in its original state, is called as its ground state in its original energy level. If we supply any light energy or any form of energy to this electron, what would happen? It would absorb this energy and it would have now excess energy and would get excited and jump out of its original energy level to a different energy level. This right here, the electron, when it is outside of its own energy level, it is called as the excited electron, or the electron is called in an excited state. But at some point, after a little bit of time has passed, this energy will be released and the electron will have to come back to its ground state. This process, when the electron comes back from the higher energy state to a lower energy state, the energy difference that is present between these two states is released, and this is usually released in form of light emission, and that is the color that we can visually see in the atomic spectra. So every time an excited electron comes back to its original state, it produces, whenever it relaxes, it produces some light energy, or it emits light, and that is the reason that we see atomic spectra. And every atom has a very different atomic spectra. That is because when the electron relaxes, its energy levels are its own energy levels, right? And when the electron relaxes, let's say electron had jumped from this energy level, the ground state was N1, and it had jumped to N3. It can jump back directly. There are multiple ways that it can jump back into its ground state. It can directly come back to its original ground state, or it can come back to this state and then it will come back from here to here. Another thing that you can see here, that the space that you see between different energy levels is completely different. For instance, this is a big difference between nucleus and first energy level. The distance between n equal to 1 and n equal to 2 is different than the energy difference between n equal to 2 and n equal to 3. So each energy level, the difference between the different energy levels is completely different. So when something jumps from 2 to 1 or from 3 to 2, even though the jump looks like just one energy level, the amount of energy that is involved in that jump is completely different. Okay, and that's why you see different colors, because each color is a different wavelength, and we saw previously that different wavelengths mean different energy. So a lower wavelength means higher energy, lower wavelength means high energy, high energy means a different color. Okay, and lower wavelength is usually, like, let's say if it's blue, lesser wavelengths are basically starting from violet, and as we go higher in the wavelength, the color changes from violet to red. So as the wavelength changes, the color of the light that is emitted is different, and that's why we see different lines in atomic spectra. Okay, now this is about atom. Now let's see how you can arrange the electrons in an atom. That is called as electronic arrangement. So after this lecture, you should be able to arrange the electrons around an atom, at least for atom until 20. Okay, with atomic number 20. From 1 to 20, you should be able to arrange atoms or the electrons in the different principal quantum numbers. What does that mean? Let's say if I'm talking about hydrogen atom, how many electrons does hydrogen have? It has one proton based on the atomic number 1, so it has one electron as well. Where would that electron be located? it would always be in shell number or the energy level number 1. Now moving on to helium. Helium has two atomic number, meaning it has 2 protons and also 2 electrons, because again it's a neutral atom. So 2 electrons, again, where would they be located? They would also be located in the energy level number 1, because 1 can hold 2 electrons. So if you were to write the electronic arrangement of helium, that would be 2. Now coming to lithium. Lithium is 3 protons, atomic number of 3, so it has 3 protons and 3 electrons. Now if we were to arrange 3 electrons, how would we arrange them? This would be nucleus in the center, then there's energy level 1 which can hold 2 electrons, so I put 2 right here, and then I have 1 more electron left, so I'll put that or place that electron in the third energy level. Therefore the second energy level. That's why you will see for lithium the electronic arrangement is written as 2, 1. So 2 electrons in the first energy level and 1 electron is in the next energy level. Similarly, you can basically write the energy electronic arrangement for all the representative elements starting from 1 to 20. Let's pick another example. Let's say if we are working with sulfur, how would we divide the or distribute the electrons around the atom? So again, if I'm talking with sulfur, sulfur has atomic number of 16. It has 16 protons, so I have to distribute 16 electrons. So I'll start with the nucleus, then I put one energy level, first energy level, can always only have 2 electrons. Second energy level, how many electrons in total? I need 16. So I have 1, 2. I'll start dividing the rest electrons in here. I have 1, 2, 3, 4, 5, 6, 7, 8. That gives me a total of 8 plus 2, 10 electrons. I still have 6 more electrons, so where would they go? They'll go in the next energy level. So this energy level would have 6 electrons now. 1, 2, 3, 3, 4, 5, 6. So essentially you are basically adding or distributing the electrons around the atom in different shells. Always start with the lowest shell at the n equal to 1. It always has 2 electrons, then add to the next shell 8 electrons. If it has 8 or whatever is left goes to the next shell, and if there's still some more left, you go to the next energy level. And that's exactly how you distribute electrons around here. Another interesting thing that you see the period number right here. When we did hydrogen, hydrogen had a nucleus and then the first energy level and 1 electron. Same is true for helium. Helium is this first energy level and then 2 electrons. So what is the outermost energy level for hydrogen? It is, and helium, it is 1, and that is its period number. Okay, how about lithium? We drew lithium right here. So for lithium, what we see, it has nucleus and then 2 electrons and then third electron in n equal to 2. So what is the outermost energy level or orbit for lithium? It is number 2, and that is which period it belongs to. Everything in period 2, the outermost shell or outermost orbit or outermost energy level is going to be 2. The second, n equal to 2. We can take another example. Let's say oxygen. How would we draw oxygen? So oxygen would have 8 electrons. So it has nucleus and then the first shell. I put 2 electrons right here. I still have 6 more electrons to go. So I draw the next shell and I'll fit 6 electrons here. 1, 2, 3, 4, 5, 6. So what is the outermost shell here? The outermost shell is 2, and you can see right here the period number gives you the outermost shell. So what would be the outermost shell in period number 3? Number 3. All these would have third outermost shell. You can see from here they have 3 shells in the outermost in the atom. How about 4? Everything in this 4 period essentially would have outermost shell is going to be 4. You can see it has 4 total number of shells. So period number gives you that information. Okay. Now another important thing right here is all the electrons. If you draw the electron arrangement around an atom, all the electrons in the innermost shells. All the electrons that are present in the outermost shell of an atom are called as its valence electrons. Okay, and what was this that we drew? I think here we drew sulfur. So this is sulfur, this is hydrogen, this is helium, this is oxygen. Let's keep that. So the total electrons, or all the electrons that are present in the outermost energy level of an atom are called as valence electrons. And all the electrons that are present in the other shells, in the inside shells, other than the outermost shell, are referred to as the core electrons. So everything that's inside is called core electrons. So how many core electron does sulfur have? It has 8, 9, 10. 10 of these electrons are core. And how many are valence? It has 1, 2, 3, 4, 5. And it had 6, right? So it should have had 6 electrons. So 1, 2, 3, 4, 5, 6. It has 6 electrons in the outermost shell. So it has 6 valence electrons. How about oxygen? Oxygen we drew was right here. How many valence electrons does oxygen have? Oxygen has 1, 2, 3, 4, 5, 6. Again, it has 6 electrons in the outermost shell, so it has 6 valence electrons. How about lithium? How many valence electrons does lithium have? Lithium has 1 electron in outermost orbit, or outermost shell, or outermost energy level. So it has 1 valence electrons. And why are we talking about these valence electrons? These are the electrons that actually are involved in an electron transfer or electron sharing with other atoms. These are the electrons that are actually involved in preparing or making new compounds, or reacting with other elements, or reacting with other atoms. So that's why valence electrons are very important. This is what makes an element or an atom reactive. Okay, so that's why we care about valence electrons. The electrons that are present in the inside, or the core electrons, are just there, but electrons that are present on the outside is something that makes atom reactive. Another interesting thing that you'll see here is that the number of valence electrons that are present in an atom is actually equal to its group number. So you can see right here, how many valence electrons does hydrogen carry? 1. What is its group number? 1. How many valence electron does lithium carry? 1. What group does it belong to? 1. So the group number essentially tells you how many valence electrons an atom has. Another example you can see is oxygen. How many was in oxygen? The valence electron was 6. Which group does it belong to? Group number 6A. So this belongs to group number 6. How about sulfur? Also 6. Where does it belong? Belongs to group number 6. How about helium? Helium belongs to group number 2. Number of valence electron is 2. You can basically pick any example from here. For instance, let's say if I'm looking for aluminum. Aluminum has how many valence electrons? Based on this, I can say it has 3 valence electrons, right? Outermost shell has 3 valence electrons. Where does it belong? It belongs to group number 3. So the group number essentially tells you the number of valence electrons. Okay, and the period number tells you what is the outermost energy level in an atom. Okay, so therefore these numbers are very important, and it's easy if the question is asking you how many valence electrons does magnesium have. You don't have to solve for its electronic arrangement. You can simply see that it belongs to group number 2. That means it has 2 valence electrons. You can also solve for it and try to distribute the electrons and then confirm your answer or check your answer, but it should come out to be equal to 2 because it belongs to group number 2. And how many shells or how many energy levels would magnesium consist of? It would always consist of 3 energy levels, like you can see right here, 2, 8, 2. Okay, so that is valence electrons. This would give you an idea of what exactly we will be talking about. So here again, this is 2 different types of compounds. One is ionic compound, one is molecular compound. First, by definition, let's make a quick definition. Ionic compound basically consist of ionic bonds, whereas molecular compounds consist of covalent bonds, and they can also have some other attractive forces. We'll talk about these later on, what exactly these bonds are. But basically for now, just understand ionic compound consists of the type of bond that makes ionic compound is ionic, and the type of bond that exists between molecular compound is a covalent bond, and they also consist of some attractive forces. The ionic compound, what is the major difference between ionic compound and molecular compound? Ionic compound consists of a metal and a non-metal always. There will always be a metal and a non-metal. So this bond, ionic bond, will always be present between metal and non-metal. Molecular compounds, on the other hand, basically only consist of non-metal. So the bond that we're talking about, covalent bond, will be only present between two non-metals. So if you see a compound, you would first identify what type of atoms is it composed of. If it consists of one metal and one non-metal, it is ionic. And if it consists of both or non-metals, or three or four, whatever you see is non-metals, it means it's a molecular compound. Ionic compound basically consists of metals and non-metals. Okay, now we'll just focus on ionic compounds for now. We'll talk about molecular compounds later on. Ionic compound consists of a metal and non-metal. The metal part here always donates or loses its electrons, and it forms positively charged ions. The non-metallic atom gains the electrons and it forms the negatively charged ion. And then these two, positive and negatively charged ion, they have attractive force towards each other, which is called the ionic bond, and that's how these compounds are made. So now to uh, go back to the definition, a compound is essentially anything that is composed of two or more elements in a fixed ratio. For instance, all of these are compounds. Why? Because you can see it consists of multiple different atoms in one compound. Ionic compound is one or more electrons are transferred from the metal to non-metal, which form positive and negative ions held together by electrostatic attraction. So basically, by definition, what we need to remember here is that ionic compound consists of a metal and a non-metal. And the second thing is, how are they formed? The metal here donates or transfers its electrons to the non-metal. There is always a transfer of electron involved here. Metal loses the electron. When something will lose electron, electrons carry a negative charge. When we lose the electron, the neutral compound essentially will turn into of something positive because it has lost a negative component. What happens to non-metals? Non-metals accept that extra electron, and because now they have extra electron, they are going to get a negative charge. So that is what happens here. Metals lose their electron and non-metals gain that electron. So basically the electrons have been transferred from metal to non-metal, and that is called that arises an electrostatic attraction between the positive and negative charge ion, which is called an ionic bond, and that gives rise to an ionic compound. Molecular compound, on the other hand, consists of two or more non-metals. Again, if it's only non-metal, it will be a molecular compound that attains stable electronic configuration by sharing electrons. So the major difference here is that these compounds share electrons. If there are two non-metals, for instance, they are going to share the electrons in molecular compound, whereas in case of ionic compound, the electrons will be transferred from metal to non-metal. So let's say if this is X and Y is a ionic compound, here X will lose the electron and transfer the electron to Y. Whereas if X and Y is a molecular compound, here X and Y are going to donate electrons and share the electrons among each other. And no transfer of electrons is involved here. Okay, particular topic. So the first thing is that when you look at the periodic table, you should be able to recognize which atoms belong to representative elements, which atoms belong to transition elements. So if I break this periodic table right here in the middle, this middle section along with this section that is outside, which is the lanthanide and the actinide series, everything that is in here, this whole section is regarded as the transition elements. And everything outside of this, which is this portion on the right side and this particular portion on the left side, group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, these are regarded as the representative elements. The next thing which we have talked about before is that by looking at this periodic table, we should be able to recognize which elements or atoms are regarded as metallic or metals and which is regarded as non-metals. So everything that we see here in blue, which is majorly on the left side of the periodic table, is regarded as a metallic element or metallic atom. Everything in the yellow right here on the right side of the periodic table is regarded as a non-metal. You can see right here, these are non-metals in yellow, metals are in blue, and everything right here in green is regarded as a metalloid, which means they can act as a metal or a non-metal. They're like somewhere in between. The next thing, moving forward, now let's try to understand when we say ionic compound. As I said, ionic compound basically will consist of a positively charged ion, metal. The metal is going to lose the electron. When it loses electron, it becomes positively charged. And this positively charged metal is now called as ion. Whenever atom carries a charge, it turns into ion. Atoms basically are always neutral, like we saw in the last chapter. If they are carrying a charge on them, that means they are now called as or referred to as ions. Metals will always lose electron. That is a tendency of metal. And now we know where in the periodic table do metals exist. So if we know that something is a metal, it will always carry a positive charge. And positively charged ions are called as cations. When an atom loses electron, it will always have a positive charge. And remember, neutrons or protons are not transferred. Only thing that is transferred in an atom is electrons. So either electrons will be lost or electrons will be gained. If electrons are lost, meaning the negative charge is lost. So what would happen to the overall charge of the atom? It will have a positive charge, and that's when it is called cation. For instance, if we talk about sodium atom, sodium is a metal. If we look at periodic table, sodium is present on the left side of the periodic table where mostly metals exist. So sodium has a tendency to lose its electron, which means usually it will lose one electron. When this one electron is lost, this sodium had a zero charge. So if we try to understand how many protons and electrons it has, you can look up the periodic table. Sodium has the atomic number of 11. If its atomic number is 11, meaning it has number of protons here is 11. Number of electrons here is also 11. Why? Because the charge is 0. So number of protons and electrons will be same. But when it loses one electron, number of protons now becomes 11, which means it has a positive 11 charge. Number of electrons now, because it lost one, it turns into 10. So it is carrying a total negative charge of 10. If you add up the total charge, meaning positive charge is 11 and negative charge is 10, the total charge that this atom would carry now is positive 1. So that is why if we lose an electron, now it has excess number of protons, so the final charge of the ion would be plus. So therefore sodium will carry a charge of sodium plus. So now this is referred to as the ion instead of atom. Atom is this, atom is always neutral, whereas ion is now completely new species which carries 11 protons and 10 electrons. So this is basically a cation now. How about the negatively charged ion? So if non-metals always have the tendency to gain electrons. Okay, so if something will gain electron, now it is getting extra electrons, so it will always carry a negative charge. And negatively charged ions are referred to as anions. Whenever an atom gains electron, it has a negative charge. The first syllable, how do you name the electron, anion? The first syllable is followed by a suffix ide and the word ion. which meaning, let's say if this is Cl, Cl is a chlorine atom. Where does it exist on periodic table? It is found on the right side on our periodic table, which makes this a non-metal. So if this is a non-metal, non-metals always have a tendency to gain electron. It will gain one electron, and what would happen? It would turn into Cl minus. Now this was chlorine, and this is, as it says, you still use the same name, chlor, and the suffix is now, instead of ine, it's changed to ide. So this is a chloride ion. That's how we name it. Now, if I were to ask you what is the number of protons and electrons in chlorine, chlorine will consist of, if you look at periodic table, it will consist of 17 protons. And since the charge is neutral, electrons is also 17. How about chloride? It has a negative charge. So basically number of protons here, again proton never changes. Proton would be still 17 from periodic table. How many electrons would it have? Originally it would carry 17 electrons, but because it has this extra negative charge, that means it has one extra electron, so it would be, total electron number would be 18. All right, now how do we know which atom would get what charge? So like I said, sodium would carry a charge of +1, and chlorine right here would carry a charge of -1. How do I know that? And how do I know, what can I predict what would be the charge of other atoms on this periodic table? The answer is yes. How can you do that? That is based on a rule which is called the octet rule. So as of now, based on last chapter, we saw that we can figure out how many valence electrons does an atom have. Valence meaning the outermost orbit. How many electrons are present in the outermost shell of an atom. That is based on the group number it belongs to. So here in this part, we are only going to focus right now on the representative elements, which means only the first two and these last groups. So we remember that the first group is group 1, meaning all of these, the number of valence electron for every atom in this group is 1. They always have one electron in their outermost orbit. How about group number 2? Group number 2 has 2 electrons in their outermost shell. 3 has 3, 4 has 4, 5 has 5, 6, 7, and 8. Okay, so here I'm talking about these representative elements and not this. We're not talking about these right now. Not transition elements, same thing, we're not talking about these. All these elements that we see in representative, if they belong to representative elements, you can predict their charge easily. If they belong to transition elements, it is difficult. How the easy way to remember this is, representative elements are also called as type 1 metals. Okay, so remember all of these are metals. So representative, as long as these metals are representative, they are referred to as type 1 metal. We can predict their charge. Whereas these transition elements, these are called as type 2 metals, where it is very difficult for us to predict what is their charge unless we are told this is the charge that it carries. Why? Because they can carry multiple charges. Now, how can we predict what is the charge of these type 1 metal and the non-metals? This is based on octet rule. Octet rule basically tells you that every atom in this representative elements basically wants to complete its outermost shell or fill the outermost shell with either 8 electrons, or it does not want any electrons in its outermost shell. So octet rule basically tells it wants to have in the outermost shell, it wants to have 8 electrons all the time. Forget about this 0. According to octet rule, every atom in this periodic table wants to have 8 electrons in this outermost shell. Exceptions to this rule is helium, which is happy with 2 electrons, and hydrogen, which only has 1 electron. Okay, both hydrogen and helium are happy with having only 2 electrons in their outermost shell. Rest everything else wants to have 8 electrons. 8 electrons meaning they all want to turn into or want to have their electronic configuration similar to the inert gases, similar to the noble gases, which is very stable. They do not like to react with anything. They are inert, that is why they are called as inert gases or noble gases. So everything wants to attain this 8 electrons in their valence shell. Just how these atoms have 8 electrons in the valence shell. Again, helium is an exception. It only has 2. It's happy with 2. So everything wants to have 8 electrons. Now, how can they get 8 electrons? For instance, if we we'll talk about hydrogen later on. If I pick this particular element right here, this is lithium. It has 3 protons, which means it has 3 electrons. So based on electronic arrangement, lithium would carry how many electrons? How would its electronic arrangement be? In the innermost, it would consist of 2 innermost energy level, and the outermost energy level, it would consist of 1 electron, which meaning its valence electron is 1. Now, what would this element want to do? It wants to turn into this helium because this is the closest inert gas next to it. So what it wants to usually do is this one extra electron that it has, it makes it very unstable. This one electron makes lithium very reactive. So being a metal, metals usually want to lose their electron. Lithium is a metal, so what it does, this extra electron that it has in the outermost shell, it loses this electrons and it turns into lithium ion, which is Li plus. That is how I can predict what is the charge of anything in this particular group. Basically, if this carries a valence electron of 1, it is a metal, meaning whenever it turns into an ion, it will lose this 1 electron that is present in its outermost shell. So if I pick anything from this group 1, it will always carry a charge of +1. If I say potassium ion, you know potassium is K, and I'm telling you it is potassium ion, which means it will always carry a charge of +1. And how do I know that? Because it belongs to group number 1. The valence electron is always 1 for all of these, which means they always want to lose that 1 extra electron that they have. How about group number 2? Anything in this group basically has 2 valence electrons. To become stable, they want to lose this 2 electrons. So for instance, if I say magnesium ion, what would be the charge on magnesium ion? We can predict that because magnesium belongs to group number 2, it will carry a charge of 2 plus or +2. It doesn't really matter. So basically what is happening, it will lose these 2 electrons and will always make a ion which is Mg2 plus. How about calcium? Which group does calcium belong to? Group number 2. So it would always carry a charge of 2 plus. Now when it comes to non-metals, so what do non-metals do? Non-metals like to gain electrons. What do? They want to always gain electrons. How many electrons? For instance, if I talk about this right here, nitrogen. Nitrogen belongs to which group? It belongs to group number 5, right here. So how many electrons maximum can it gain? Again, remember everything wants to have 8 electrons in its outermost orbit. So how can nitrogen have 8 electrons? In order to have 8 electrons, it needs 3 more electrons. It already has 5. It can turn into 8 by gaining 3 electrons. So nitrogen, if I tell you it is an ion formed from nitrogen, it will always consist of a charge of -3 or 3 minus. Why? Because it needs 3 more electrons to turn into a stable ion. So how can you predict that? Basically look for the non-metal, which group does it belong to, and do 8 minus that particular group number. Whatever that subtraction gives you, that is the number of electrons it wants. For instance, let's say sulfur. Sulfur is right here. It belongs to group number 6, which means what would be the charge on sulfur? If we were to predict, sulfur would be 8 minus 6, which is -2. So 2, which means it would carry a charge of -2. How do I know it's negative? It's a non-metal. It will always gain electron and it will always form an anion. How about bromine? What does bromine do? Bromine ion, if I'm talking about the ion, what would be the ion here? It is group number 17 or group number 7. 7 means 8 minus 7 is 1. So bromine will always turn into Br minus 1. Now what would be the name of this ion? The atom is called bromine, and when we turn it into ion, it will be called bromide ion. Same thing, nitrogen will be called nitride ion. Sulfur will be called sulfide ion. So always it would end with IDE at the end, followed by ion. That is the name of the non-metal. For metal, name is simple. If it is sodium, it is sodium ion. You basically just put the ion at the end. Lithium is lithium ion. Calcium is calcium ion. Barium is barium ion. How about aluminum? Aluminum is right here. It belongs to group number 3. So aluminum will always carry a charge of plus 3 or 3 plus. And this is called aluminum ion. Alright, and rest we'll talk about type 2 metals in a little bit. These type 2 metals, what you see right here in the middle, which is the transition elements, they can have multiple charges because their final aim is still the same. They also want to have 8 electrons in their outermost orbit, but they are not as straightforward or as simple as representative elements. They are more reactive. They can attain stability by losing different number of electrons. So they can sometimes carry even 7 different types of ions. They can basically make multiple different types of ions, and we'll talk about those later on. But for now, you should understand how representative element, if something belongs to representative element, how can we predict what would be the charge? If it's a metal, it will always be a positive charge. If it's a non-metal, it will always be a negative charge. So based on this rule, you should be able to predict the sign and the charges for these particular metal and non-metal, and also know their names. So phosphorus, again, it belongs to group 5. 5 means 8 minus 5 is 3, so it would be 3 minus. The name would be changing from phosphorus to phosphide. Oxygen will be oxide. Sulfur, sulfide. So you should know these names. Memorize what is their name, memorize their charge. Charge is easy, you just look the periodic table and you should be able to figure that out. Okay, now let's talk about how can we come up with formula for ionic compounds. The easiest way to figure out the formula for ionic compound is we basically write down in a chemical formula of an ionic compound will consist of the symbol and the subscript of an atom. The subscript is essentially telling you what is the total number of atoms that are present or ions that are present. And that number, the subscript, should always be the lowest whole number ratio between two atoms. For instance, if I say sodium chloride, an ionic compound, can you predict what would be the ionic compound between sodium and chlorine? So first thing we need to be able to identify this would be an ionic compound. So if I'm saying sodium and chlorine, that means sodium is a metal, chlorine is a non-metal. So I know metal non-metal makes ionic compound. Next thing, I should be able to predict the charge of this metal. Sodium would be Na plus, chlorine would be Cl minus. Now what would be the formula for this compound? The easiest approach is ionic compound will always have a total charge of 0, which is neutral. Ionic compounds are always neutral. The total charge is 0. So we want to see what is the total positive charge in this compound. As one sodium carries one positive charge, so it is a total of +1 charge, and chlorine is total -1 charge. So here the total charge of positive and total negative charge should be equal to each other. They basically are trying to neutralize each other. So to neutralize one sodium ion or one sodium cation, we need one chloride anion. Therefore, the formula for this is NaCl. One sodium can neutralize one chloride ion. How can you do that? You basically take this charge. The easiest way is you take this charge and make whatever is the number next to this charge would become the subscript for the second atom. This charge of the non-metal would become the subscript for the metal. So you basically crisscross these numbers, only the numbers. We don't care about the charges. So this is 1. If nothing's written, that means 1. So Na would be 1 because of Cl, and Cl would be 1 because of sodium, and the final formula would be NaCl. And this is the lowest ratio possible, 1:1. Therefore, the formula would be NaCl. Similarly, let's say pick another example. If we were to talk about magnesium and chlorine, instead of sodium, let's say we are working with magnesium and chlorine. What would be the formula? Magnesium belongs to group number 2, so it would carry a charge of 2 plus. So magnesium would be Mg2 plus, and chlorine will be Cl minus 1. Now, crossing over the numbers, magnesium and chlorine. So it would be Mg would be 1. You need 1 magnesium atom, and we need 2 chlorine atoms. Whatever is the number becomes the subscript. Now to explain this, basically each magnesium carries a total charge of +2. To neutralize 1 magnesium atom, we need 2 chlorine atoms, because each chlorine carries, or each chloride carries, a total charge of -1. So to neutralize each magnesium, we need 2 chloride ions. So that is why the formula becomes MgCl2. To neutralize each magnesium, we need chlorine. How is this formed? So magnesium has 2 extra electrons. One of these electrons was donated to 1 chlorine, the second was donated to second chlorine, and that's how it lost its 2 electron, turned into Mg2 plus. And these chloride, each of them gained 1 extra electron, and they turned into Cl minus. And now because they have this charges, they have this electrostatic force of attraction, and that turns them into a compound. Okay, we can pick multiple examples. For instance, let's say if we are making a compound between calcium, again it has to be a metal and a non-metal. Let's say calcium and bromine. Okay, can you predict what would be the formula of a compound between calcium and bromine? Calcium carries what charge? It belongs to group number 2, and it's a metal, so it would always be +2. How about bromine? Bromine is a non-metal, so metal non-metal means ionic, therefore I'm putting ionic charges. Bromine would be -1. Why? Because it belongs to group 7. Now crossing over the charges would give you a formula of calcium would be 1 and Br would be 2. To neutralize charge of each calcium ion, we need 2 bromide ions, and that would be our total formula, or final chemical formula. Okay. Now, if the formula is given to you, what would be the name of the compound? How can we name the compound? Whenever we are naming the ionic compound, an ionic compound will always consist of name of the cation followed by name of the anion. Oh, one thing, a formula will always consist of cation first and then the anion. So you always write the positive charge ion first followed by the negative charge. You would never write BrCa. It would always be CaBr. Metal comes first and then the non-metal. So formula would always be metal followed by non-metal. How about name? Same rules apply for the name. You always put name of the metal followed by the name of the non-metal with IDE. Okay. So when naming an ionic compound, the name of the metal is written first, and then and it is same as the name of the element. The name of the non-metal is the first syllable of the non-metal name followed by IDE as the ending, meaning whatever is the name of the anion. Anion is always IDE, except you remove the ion part. So for instance, if you're talking about potassium Ki, this is first thing you can identify its ionic compound. Potassium is metal, iodine is non-metal. So if we were to name this is a type 1 metal, meaning we can predict its charge. Iodine is always I minus. What is the name of the metal? Metal is named as potassium, and this is named as first syllable of non-metal followed by IDE. So it would be iodide. So name would be potassium iodide. MgBr2 would be magnesium, and bromine would be bromide. So magnesium bromide. We do not put these numbers in the name. These numbers, we don't care about these numbers in the name. They do not show up in the name of the compound. Basically, MgBr2 is only magnesium bromide. There's no 2, there's no di, nothing. Al2O3, Al is a metal, O is a non-metal, so this is ionic compound, meaning you put name of the metal first, which is aluminum, followed by name of the anion, which is oxide here, so it would be aluminum oxide. Next thing, if right now we saw how we can go from the, if I give you the name of the atoms, or if I tell you which atoms to come up with the formula, can we go from the name to formula? So if we say potassium iodide, can we write the formula for that? How would we do that? Potassium iodide means this is metal, potassium is metal, this is non-metal, so this is ionic, meaning it has positive and negative charge. So potassium belongs to group 1, so it would be +1. Iodide means it belongs to group number 7, so it would be -1. And now crossing over the charges would give you potassium iodide, Ki. Aluminum oxide, aluminum is group 3, so always 3 plus. Oxygen is group 6, 8 minus 6 is 2, so it would be -2. Now crossing over would give you Al2O3. That is why this is aluminum oxide. Okay. When we say lowest charge, let's take an example of calcium oxide. Can we make up the formula for calcium oxide? Calcium is Ca2 plus, it belongs to group number 2. Oxygen belongs to group number 6, so it would be 2 minus. So crossing over the numbers would give us calcium 2, oxygen 2. Now this is also 2, this is also 2, so we need the lowest ratio. Lowest would be that we divide both of these numbers by 2, and that would give you CaO. Ca would become 1, 2 divided by 2, and 2 divided by 2. It would give you Ca1O1, which meaning CaO. That would be the actual formula. So if your numbers are coming out to be same, or if your number is not the lowest whole number ratio possible, then you need to turn it into the lowest ratio possible. For instance, calcium oxide. If nothing is written here, that means it is one atom. Okay. You can practice these questions. For instance, let's say sodium Br, write the formula and name of the compounds of the volume. Sodium with Br minus, Na plus, Br minus, crossing over the charges would give you 1 Na, 1 Br. That is the formula. Name would be sodium. Name of the ion is bromide. So sodium bromide. You leave a space. There should be some space between cation and the anion name. Sodium with S2 minus. S2 is sulfide. This is sodium. So sodium would be Na plus. Sulfide is S2 minus. Crossing over the numbers would give you Na2S. This would be sodium. You put the name of the metal followed by name of the anion, which is sodium sulfide. How about sodium and N3 minus? N3 minus comes from nitrogen. It is nitride. So Na plus, N3 minus would give us, crossing over the charges, would give us Na3N. This is sodium nitride. Whatever is the name of the ion basically follows that. Aluminum and Br. Aluminum is 3 plus, Br is -1. Crossing over the charges would give you Al Br3, which is aluminum bromide. How about this? This would be Al3 plus, S2 minus would give you Al2S3, which is aluminum sulfide. Aluminum and nitrogen will give you Al3 plus, N3 minus, Crossing over the numbers would give us Al3, N3, and again we want the lowest ratio possible, so we'll be changing that in this into Al(N). That would be a formula. Both can be divided by 3. The lowest ratio possible is 1:1. This would be again aluminum nitride. Okay. Now these are all the examples when we are talking about representative elements where we can predict the charge on the metal. Here we have select the correct formula for each of the following ionic compounds. Na plus O2 minus, crossing over the charges would give you Na2O. So answer is B right here. Al3 plus Cl minus, crossing over the charges would give you Al1Cl3. So AlCl3, answer is A. Mg2 plus N3 minus would give you, crossing over the charges would give you Mg3N2. So Mg3N2 is C, so answer is C right here. Now this is when we talk about cation and anion monoatomic. What do you see here? That each of these cation or anion consists of one atom. So sodium has one atom, aluminum ion is one atom, oxide ion is one atom, chloride ion is one atom. So all of these are one atom ion. There is also something which is called as polyatomic ions. Polyatomic ions basically are the ions which consist of a group of atoms. So bunch of different types of atoms come together to form a polyatomic ion. For instance, most of the polyatomic ions that you will see are going to be anionic in nature. Anionic meaning they'll carry a positive negative charge. There's only a couple examples, which is cation. Okay, most of these anions will consist of non-metal such as phosphorus, sulfur, carbon and nitrogen along with oxygen. So most of them consist of oxygen along with something else. The positive charge cation that we usually see is ammonium. NH4 plus is called ammonium. You should know this name and this formula for the polyatomic ion. You do have to memorize some of the polyatomic ions, their names, their charges, what is the usual charge they carry, and their formula. So ammonium ion is NH4 plus. It consists of, you can see two different types of atom, N and hydrogen. It consists of one N nitrogen and four hydrogen atoms combined together and has a charge of +1. That's why it is cation. This is showing you some other examples of polyatomic ions. You can see most of those are negatively charged, except there's this one which is ammonium positively charged. So you need to memorize these. You should know which ion is what. So OH minus is called hydroxide. You should know this formula, that hydroxide ion is OH minus. It carries a -1 charge, and you should also know the name. NO3 minus is nitrate. NO2 minus is nitrite. CO3 2 minus is carbonate. HCO3 minus is hydrogen carbonate. Cn minus is cyanide. These are some common names of very commonly found ions, polyatomic ions, that you should know the name, formula, and the charge. Okay. The questions would basically sometimes, most of the times, when you see certain ions, um, the way they are named, there's some trend for some of them. Most of them you kind of have to memorize, but some of them there is some trend. For instance, you'll see S and O, they form a polyatomic ion SO4 2 minus and SO3 2 minus. They both have same charge 2 minus, but the difference is number of oxygen atoms. If we are talking about atoms like polyatomic ions like this, most of the times the naming is following a format where the one which has higher number of oxygen atoms is ending with 8. The one which has lesser number of oxygen atoms is ending with ITE, so IT. For instance, this is sulfate, this is sulfite, and usually this is when it has one less oxygen. This is between P and O. It has PO4 3 minus, this is PO3 3 minus. So this is phosphate ending with 8, this is phosphite. Similarly, N and oxygen can have NO3 minus or NO2 minus. NO3 minus is called nitrate, whereas NO2 minus is called nitrite. Okay. Exception to these rules are here. For instance, Cn minus is called cyanide, OH minus is called hydroxide. Whenever we add a hydrogen to a polyatomic ion, we add a +1 charge to its charge as well. For instance, you see CO3 2 minus is called carbonate. If I add a hydrogen plus to this, it will turn HCO3 minus, and the formula became HCO3. Charge became, you basically are adding this one charge, so total charge would be 2 minus plus 1, which would give you -1. This is called either the bicarbonate ion or hydrogen carbonate ion. Same thing if we have sulfate ion, SO4 2 minus. If I add a hydrogen to this, this would turn into HSO4 and one less negative charge, so -1. This is called either bisulfate or hydrogen sulfate. Usually you add this alphabet prefix of bi or you add hydrogen in front of it. So it's become either bisulfate or hydrogen sulfate. There are some more examples of between chlorine and oxygen. So you can see here, these are 4 different, chlorine and oxygen can form 4 different types of polyatomic ions. Now we'll see how, if we are talking about polyatomic ions, how can we write the formula for polyatomic ion? So let's say if I'm making a compound between magnesium ion and nitrate ion. So first thing, I need to know what is the formula for magnesium ion. Magnesium is Mg2 plus. Nothing has changed here. This is a metal, second group. How about nitrate? Nitrate is NO3 minus. How do I know that? Memorize it. Okay, there's nothing else here. You do have to memorize certain names. Nitrate is NO3 minus. Now, whenever you see a polyatomic ion, remember this, everything stays together. NO3 never changes. Okay, here everything will stay together. You can basically regard this in parentheses, that this always stays together. You cannot break nitrogen and oxygen apart. And the charge that you see here is the charge of the complete polyatomic ion. So you cannot move this around. The easier way is you could put a parentheses outside of this, and remember this stays together. And now we do the exact same thing. So if polyatom, whatever is the charge of the cation, becomes the superscript or the subscript for the anion, and same goes for the other ion. So basically you do the crisscross rule again. Now Mg, we need how many? Just one. NO3, keep it together, we need how many? 2 of those. So put a parenthesis and then put 2. So you're telling me you need 2 nitrate ions, meaning you need 2 nitrogen and 6 oxygen atoms. Okay? That is why we put a 2 right here. Whenever you open this 2, that means this compound consists of 1 magnesium, 2 nitrogen atoms, and 3 times 2, 6 oxygen atoms. Okay, so you should always put this 2 should always be outside the parentheses, meaning you need 2 nitrate. Nitrate is now regarded as one species. It always stays together. So that is why the formula is MgNO3 2. You need 2 nitrate ions. Okay, everything else stays the same. Only thing you have to remember here is that you should put this in parentheses and nothing changes. Okay. So for instance, if we are talking about aluminum bicarbonate, can we come up with the formula? Aluminum is what? Aluminum is always 3 plus. Bicarb is HCO3 minus. Again, memorize this. So now if I'm crossing over the charges, remember this whole thing stays together. So this crosses over here, this number crosses over right here, so it will turn into Al1HCO3. Keep it together. How many of these? 3 of these. So now if you're looking at this particular compound, it consists of 1 aluminum atom, 3 hydrogen atom. When you put something right here in the bottom, remember that is the number of atoms. And because it is parentheses, it means there's like 3 of hydrogen, 3 of carbon, and 3 times 3. So each HCO3 carries 3 atoms of oxygen. So 3 of those would carry 3 times. So 3 times 3 will give you 9 oxygen atoms. Right? Now the question comes, okay, let's try this one as well first. Sodium phosphate. So sodium is again Na plus. All of these are type 1. Okay, you should be able to identify type 1. If it is type 2, it will always consist of parentheses. Phosphate is PO4. 3 minus. So this again, how do I know this? I've memorized these, so you do need to memorize these. Now again, phosphate, remember this whole thing PO4 stays together and this is the charge. Now crossing over the numbers would give us 3 of sodium and phosphate would be 1. So if it is 1, you don't have to put any parentheses, you don't have to, because there's no multiplication here, there's no extra number of phosphate required, so you don't have to put it in parentheses. It's basically 1, so you can write this as Na3PO4. Okay. Now the question is, can I do reverse? If the formula is given to you, can you go back to the name of this? How would we do that? Again, naming is simple. Naming is you write the name of the metal followed by name of the anion. Name of the cation, name of the anion. What is this? This is type 1 metal, so I know type 1 always carries the same charge, so I don't need to show what charge it has. So you can basically write aluminum, and this you know is bicarbonate ion or hydrogen carbonate ion. Again, this is something you have memorized, so you put the name of the metal followed by name of the polyatomic ion, just like we were doing before. So this would be aluminum bicarbonate. Okay, for instance, let's say if we have this particular molecule, how can we name this? This is, I know this is a metal, sodium, and this is polyatomic ion, so I know this is definitely ionic in nature. How do I know this is SO4 is polyatomic ion? I've memorized it. That's why when I see it, my eyes can recognize them. Okay, so how do I name it? You basically name sodium, put the name of the metal followed by name of the polyatomic ion. This ion is called as sulfate, so it would be sodium sulfate. You do not care what the number is. Again, there is 2 sodium, we don't show it in the name. As long as it is type 1, you don't care about anything else. Okay, but what happens if it is type 2? If it is type 2 metal, you do have to identify what exactly is an acid. There are a couple definitions given based on how acids behave in water. So one of those definitions is given by Arrhenius. According to Arrhenius' definition, acids are anything that produce hydrogen ion when they are dissolved in water. Hydrogen ion is basically H plus ion. So for instance, one very commonly used acid that you might have heard of in chemistry is hydrochloric acid, which is HCl. Okay, hydrochloric acid, when dissolved in water, it would dissociate to give H plus ion and the Cl minus ion. Okay, so most of the times acids in water produce a positively charged proton and then a negatively charged ion or polyatomic ion, depending on whatever the compound is. How could you recognize if something is an acid or something in water? Essentially, we'll talk. Actually, let's first. How could you identify something is an acid? when you look at the formula, most of the times acids, the formula is going to start with a hydrogen and a non-metal or a polyatomic ion. Basically, the idea is that acids always, their formula will start with hydrogen in the beginning, most of the times, except for few acids. Most of them are going to start with a proton in the beginning. And if you talk about name, most of their names are going to end with acid at the end. Okay, so for instance, hydrochloric acid, its name ends with an acid, so that tells you this is an acid. Now, how do you actually name an acid? If you look at this particular formula, it has hydrogen ion in the beginning and Cl minus, which means we know this is an example of an acid. Now, what are the rules for naming an acid? If it is basically consists of, if the acid consists of only a proton followed by a non-metal, in that case we usually use the prefix hydro. So the name would usually start with the prefix hydro. So this portion will be named as hydro, followed by whatever is the name for this particular non-metal, followed with an ic acid. Okay, so it's just the middle name of this particular followed by ic acid. So for instance, this is hydro. This Cl is called chlorine or chloride, right? Remember, the ion is chloride, so we would replace the IDE at the end with ic acid. So the name would be hydrochloric acid. Okay. Other example we could think of, for instance, if we say HBr, that's another example of one of these acids. So what you see here, it starts with an H and there is a non-metal next to it, which means this is also an example of an acid. So how would the name be? It would be hydro, and ion is called bromide, so instead of ide it would be bromic acid. Similarly, you could have other acids like hydrofluoric acid, iodic acid. Okay, for instance, if we say HCN, again, you know, this is hydrogen, right? And this is cyanide ion, right? So in this case, this would be called as hydrocyanic acid. Okay, now there are also some other types of acid which have a different kind of terminology when it comes to naming them. Those are the acids with oxygen in them. Those acids are called as oxyacids. So they usually consist of hydrogen followed by a polyatomic ion which consists of oxygen in there along with some other atoms. Okay, so let's say there is an X, Y, Z, whatever, but along with that there is also an oxygen present in there. How do you name those? Basically, for naming those acids, we usually just put the name of this. In case of these acids, you usually don't have the prefix hydro. You simply just use the name of the polyatomic ion and followed by an ic acid or an us acid. Okay, what does that mean? You name the polyatomic ion, and if the name of the polyatomic ion ends with an 8, it would be changing into ic acid. Example, let's take an example which is HNO3. Okay, so if you remember, first thing you should be able to identify this is an acid, which you can see from the formula where the chemical formula is starting with hydrogen. So since here it is starting with hydrogen and there is oxygen and some other atom in the middle, that means this is example of an oxy acid. Okay, now how do you name it? There is no hydro here. You basically take name of the anion. What is the anion here? This is a polyatomic anion. If you guys remember, NO3 minus is nitrate ion. Okay, so now what would be the name of the acid? You take the name of the polyatomic ion. If the name is ending with 8, you replace the 8 with ic. So name is going to be now, nitric acid. Okay, other example is, for instance, you see this ion ClO3 minus is called chlorate, and if you see an acid like HClO3, you know this is chlorate, so name is going to be chloric acid. Okay. Some other examples could be, let's say if you look at H2SO4. So in this case, what do we know? We know this is an acid because the formula starting with hydrogen, and we know this is an oxy acid because it has oxygen and some other non-metal in there, right? So what is the name of this ion? This is sulfate, which means what is the name of the acid? Here is going to be sulfuric acid. Okay, this is a little different. Here we just don't call it sulfic acid, it is sulfuric acid. Okay, so these are some of the examples of the acid naming. How do you name an oxy acid? Sometimes if your ion, polyatomic ion name ends with "ite," for instance, if I say HNO2, HNO2 again, it's an acid starting with hydrogen. What is the name of this ion? NO2 minus is nitrite ion, right? If this is nitrite, the whole acid is going to be called, you replace the ite with us, so it is going to be nitrous acid. Okay, for instance, another acid you see here is HClO2. Here again, you know, this is an acid, and ClO2 minus is called chlorite. You can see right here, it is called chlorite ion. So if this is chlorite, what would be the acid called? Acid would be, you replace the ite with us, it would become chlorous acid. Okay, other example could be, you could take H2SO3. Again, this is hydrogen, so starting with hydrogen, it's an acid. What is this ion called? SO3 2 minus. This is SO3 2 minus. This ion is called sulfite. Okay, this is again from the naming of the polyatomic ions. If this is sulfite, what would be the whole acid called? Sulfurous acid. Okay, other example could be, let's say if I say H3PO4. H3PO4 is coming from phosphate ion. This ion is called phosphate. The name is ending with 8, so the whole acid would become phosphoric acid. Okay, next if we talk about H3PO3, this is also coming from, what is this ion called? This is called phosphite. So the name of the acid would become phosphorus acid. All right, so these are some of the rules of how you can identify if something is an acid when you look at the formula, or if the formula is given to you, how would you name the acids? Okay, all right, so this was talking about Arrhenius acids. So what do they do? Here are some of the examples like we were talking about. Now, what we saw by definition is an acid. An acid is something that when you add it to water, for instance, if you have HCl in water, you could write it in this form. In presence of water, it is going to dissociate to give us proton, which is again ion, so it would be aqueous, it would be surrounded by water, and whatever is left over would be the next anion, and since it's also charged, it will be surrounded by water. So these are called acids. This right here, what you see, H plus, is called as proton. So most of the times you would see people don't call it a hydrogen ion, they call it a proton. So acids usually donate or they lose their proton. Okay, and what is this? Why do we call it proton? So if you think of hydrogen, hydrogen consists of, if you have just the atom, it consists of one proton and one electron and one neutron, right? When this changes into H plus, what are we left with? It has one less electron, right? It lost its electron, H plus, meaning it lost the electron, so it has no more electron. What is it left with? One proton and one neutron. Therefore it is also referred to as a proton sometimes, because it only has one proton left over. Okay, all right, so sometimes actually we write a reaction like this, but sometimes acids in water can also be written in this form. So if you take acid, you add water to it, let's say this is liquid, this is, it could be gas or it could be aqueous, whatever you want. What would happen? This acid is going to donate its proton to water, and water is going to accept that proton. Acids, by definition, they lose their proton, they produce proton in water, right? Now what would happen? This was H2O. This HCl is going to lose its H plus and it will be donated to water. Water will accept it. It will have one extra proton, so instead of H2, it now will be H3O plus. Why plus? Because it accepted that one extra proton and that proton had a positive charge. So now the whole molecule here will have a positive charge, an ion here. Okay, this would be again, this is also sometimes interchangeably used as a hydrogen ion, because hydrogen ion by itself really doesn't exist. Whenever there is this hydrogen ion is present in water, it will be present as H3O plus. Okay, and what's left? It's same. What's left is this. This is Cl minus, which is chloride ion. This is referred to as hydronium ion. Okay, so basically proton, which is hydrogen ion, or hydronium ion, they can be regarded as the same thing. Okay, this is also hydrogen ion in water. You see the aqueous sign. This is basically hydrogen ion in water as well, which is added to water. So this actually doesn't exist. This is how it usually exists, but they are used interchangeably. So in case you see them being used interchangeably, don't get confused. Okay. All right, now let's talk about bases. So what are bases? According to Arrhenius definition, a base is anything that would produce hydroxide ion in water. For instance, you have NaOH. NaOH is sodium hydroxide. This is an example of a base. In water, what would it dissociate to give us? It would dissociate to give us sodium ion, which is Na+, and what's left over is hydroxide ion, so it would be OH minus. So if anything produces OH minus or hydroxide ions in water, that is called a base. Okay. Some of the common hydroxides are NaOH, KOH, VaOH, aluminum. Okay, we'll come to naming AlOH whole thrice. So these are some common hydroxides producing bases. How do you name them? You simply put the name of the cation followed by name of the anion, which is hydroxide. So this is sodium ion, hydroxide ion, meaning sodium hydroxide, potassium ion, hydroxide ion, potassium hydroxide, barium ion, hydroxide ion, barium hydroxide, aluminum ion, hydroxide ion, so aluminum hydroxide. You simply write the name of the cation followed by the anion, and that is your name of the Arrhenius bases. Okay, so they would produce, the major difference between acids and bases are acids produce proton, whereas bases produce hydroxide. Instead of producing, you would sometimes see they can also be called as acids donate proton, because they produce proton, so they lost it, they gave it to somebody else, and bases donated hydroxide. Oops. Either you could say they donated hydroxide or they accept this proton. Okay, we will talk about this. Where is this acceptance? Let's keep going. So for instance, you can see here, match the following formulas of acids and bases with their names. So HNO2, remember this was nitrous acid. Why? Because this is nitrite, it changes to us, so this is nitrous acid, so this is D. Then we have, this is a base because it has hydroxide ion, so it is going to be named by calcium hydroxide, easy, so it is E. Next we have H2SO4. Again, I know this is acid because the name is formula is starting with hydrogen. This ion is called sulfate, so it would be sulfuric acid, which would be B right here. Next we have HiO3. Here we know this is coming from a ion. Okay, so this is going, it's no longer going to be hydro because this is a polyatomic ion or oxy acid, and this is called the iodate ion, so this is going to be iodic acid, which is Okay. Last we have NaOH. Again, this has a OH group, meaning it has hydroxide. So it is a base. Name would be sodium hydroxide. So answer is C.